Hi, welcome to Topic 2, Part 2 of Data Modeling Fundamentals. In this topic, we focus on data relationships, the backbone of how tables in your model work together. Without proper relationships, even the best visuals cannot produce accurate insights. Let's dive into how tables connect and why relationships matter. In this part, we explore how different tables link to each other and how these links affect your report. You will learn how to identify relationship types, how to manage them, and how to design a model that is both efficient and accurate. To master data modeling in Power BI, there are 6 core concepts you must understand. First, primary keys, unique identifiers inside tables. Second, foreign keys, fields that reference those primary keys. Third, cardinality types, such as one-to-one or one-to-many. Fourth, managing relationships, including editing directions and activation. Fifth, schema designs, especially the star and snowflake schema. And finally, table connections, which is the practical skill of linking tables properly in the model. This slide explains how primary keys and foreign keys work in a data model. Primary keys are unique values that identify each row in a dimension table. For example, a unique product ID in a product list. Foreign keys appear in fact tables and point back to those primary keys. In the example shown, the fact table uses product IDs and dates as foreign keys, which connect to the calendar and product lookup tables. This relationship allows Power BI to filter, connect, and aggregate data across multiple tables accurately. A common question students ask is, can't I just merge everything into one big table? The answer is yes, you can, but it's extremely inefficient. Merging tables introduces redundancy, increases memory usage, and slows down the model. A relational model using smaller connected tables is significantly more efficient and cleaner. This is the model view in Power BI. It visually represents how tables connect. Here, you can inspect all relationships, see cardinality, and identify problems such as inactive or missing relationships. This view is essential for understanding how your report behaves. There are 2 main methods to create relationships. First, the drag and drop method. Simply drag a field from one table to the matching field in another. Second, using manage relationships. Power BI will detect and suggest relationships, and you can approve or edit them. Both methods achieve the same result, but the dialog box provides more control. To modify a relationship, you can double-click it or open the Manage Relationships window. Here, you can activate or deactivate relationships, change cardinality, and set cross-filter directions. These settings directly influence how filters propagate across your model. The star schema is the simplest and recommended structure. One central fact table sits in the middle, surrounded by dimension tables. The snowflake schema expands this design by adding sub-dimension tables, which normalize the data further. Power BI performs best with a clean star schema, but snowflake structures can be used for complex datasets. Relationship cardinality. On the one side, this refers to the dimension table, where each key appears only once. For example, in the product table, each product appears a single time, so every product key is unique. Each row contains the attributes of a specific product. On the many side, this refers to the fact table, where the same key can appear multiple times. For example, in the sales table, a product key may appear many times because one product can be sold repeatedly. This results in multiple sales records linked to a single product. Ideally, all relationships should follow one-to-many cardinality. Here we have an example of a one-to-one relationship. Each product ID appears exactly once in both tables. However, when both tables contain unique attributes, it may be better to merge them into a single dimension table. One-to-one relationships are less common and usually indicate an opportunity to simplify the model. Example: many-to-many cardinality. A many-to-many relationship occurs when both tables contain duplicate keys. For example, multiple instances of product _ID in both tables creates many-to-many relationship warning. This creates ambiguity. Power BI cannot determine which value matches which. For example, how would we know which product was actually sold on each date? Is it cream soda or diet cream soda? Many-to-many should be avoided unless there is a very specific modeling need. Connecting multiple fact tables. When working with multiple fact tables, never link them directly. No primary, foreign key relationship between fact tables. Connect through lookups. They should connect to related lookups, not to each other. This ensures both fact tables can be filtered consistently using the same dimensions. This is important. Fact tables should connect through shared dimension tables, not directly to each other. Here are the key takeaways for building strong data models. Understanding and applying these core principles will significantly enhance the performance and clarity of your data models. First, prioritize efficient relationships. Use primary and foreign keys to structure your data properly. This helps avoid unnecessary merging and keeps your model clean and efficient. Next, master the model view. The model view is your main workspace for visualizing and managing relationships. A well-designed model helps maintain data integrity and ensures filters work as expected. Third, aim for one-to-many cardinality. The best practice is to link dimension tables on the one side to fact tables on the many side. This improves performance and produces accurate aggregations. Finally, connect fact tables through dimensions. Avoid linking fact tables directly. Instead, use shared dimension tables to maintain consistent filtering and prevent analytical errors. By applying these principles, your data models will be clearer, faster, and more reliable.